How's it going? So, as I said in previous tutorial, from the next day, which is today, I'm going to start talking about this book from the chapter 1, actually chapter 2. So, because chapter 1 is very, very, very introduction, which we don't need, like preface, we don't need that. So, I have the book here, and I have the PDF in front of, in the screen, so you can see. So chapter 2, which is actually start from this chapter because the preface is so introduction. So what is machine learning? I'm not gonna use this book because I already have the PDF in my laptop. What is machine learning? First, it is going to explain about the date, when does it come, and where does it come from, and how they create these or this kind of thing. So as you can see, in this day, IBM published a paper in the IBM Journal of Research and Development with an at the time obscure and curious title, authored by blah blah blah. The paper invested the use of machine learning in the game of checkers. So first of all, it's talking about the game of checkers. So in this date, they use machine learning, the use of machine learning, like invested the use of machine learning in the game of checkers to verify that to verify the fact that the computer can be programmed so that it will learn to play a better game of checkers than can be played by the person who wrote the game. So so in this uh big from the beginning, it just talk about the date, like the game, like IBM Journal of Research, and so on. Even it is going to talk about the people here. Arthur Samuel introduced machine learning in his paper as a subfield of the computer science that gives the computer the ability to learn without being explicitly programmed. So traditional programming way, like the traditional programming is like web development, for example, like backend development. Like imagine there is no machine learning. How traditional programmers they program and they develop software. They're gonna be like, okay, if someone click on this, do this. If someone do that, do that. 2 plus 2 is always 4. Always 4. There is a predefined answer for everything. Like in a website, if you go to google.com slash, for example, home, whatever. So backend developer, traditional backend developer, they're gonna be like, okay, if someone send a request to this URL, show this page. So predefined answer. 2 plus 2 is always 4. Predefined answer. So like like we're gonna give the answer already to computer, and whoever asks that question, the computer gonna give the answer which we already give. But machine learning is not like that. Machine learning is like we're gonna give the ability to machines to learn from data and make a decision by themselves based on the data which they learn. So there is no predefined answer. So Samuel introduced machine learning in his paper as a subfield of computer science that gives computer the ability to learn without being explicitly programmed. Almost 6 decades later, this definition remains widely accepted, although not directly mentioned in Arthur Samuel definition. A key feature of machine learning is the concept of self-learning. This refers to the application of statistical modeling to detect pattern and improve performance based on the data, which I said. So it is going to talk about that, and here we have a picture, we have the input, we have the model, we have the output. So always the input in machine learning is data, and model is standing in the center, which is going to learn from the input and give you the output. But traditional way is like input is already predefined and the output, actually, like the input is already predefined and the output is already predefined. There is no model. So this model gonna make a decision like machine learning based on the data, but in predefined programming it's not like that. Look, an example of an input comment is saying 2 plus 2 into programming language such as Python and hitting enter. 4. this represents a direct comment with a direct answer. So predefined input, predefined output. So for this input, we always have the same output. But in machine learning, we don't have that. It's not like that. So in machine learning, 2 plus 2 is not always 4. Like that's example, right? In machine learning, it's not always 4 because machine gonna learn from the data and gonna make a decision based on the data. So machine is gonna, like I can say, think simulation of the human, how the human works. Like example, you're gonna tell to me, I'm gonna tell to you that, okay, tomorrow I'm gonna put video in my YouTube channel. Tomorrow I'm going to put, and then I'm gonna be like, okay, every day I'm going to put, every day I'm going to put. After 10 days, I'm going to get tired. I'm gonna be like, oh, I'm tired. I'm not going to put anymore. So I change my mind based on the situation which happened to me. For example, I go gym. For example, I go to school. For example, I was so tired. I didn't feel good. So see, I'm making decision based on the data. What is the data in this situation? The data is the situation. Like the I'm going gym, I get tired. I'm going work, I get tired. Like whatever. So it's data. I'm making decision based on data or based on the thing which happened to my life. But it's not predefined. Predefined is like that. Programmers. Always. 2 plus 2 is 4. Always. In human. If we were predefined human, I'm going to go gym every day. There is no excuse, no situation, no data. Even though if I'm going to lose my hand, still I'm going to go gym. Even though if I'm in hospital or something happened to me, I'm going to go gym. So it's like I'm not going to make a decision based on data which happened to me. But in machine learning, it is going to make a decision. So how it works, like in real world project example, I can say, for example, house price prediction. We're programmer gonna give like huge numerous amount of data, huge amount of data, which in that data set we have some variables like the model of the house. I mean, house doesn't have the model, but anyway, house, how many bedroom does it have? Like, does it have swimming pool or not? Or how many meter it is? So based on these variables, we're gonna have the value as well. Okay, this house is $1 million or $2 million, and then imagine that like 200,000, like 2 million thousand field same, like we're gonna give to machine, which is data, and then machine gonna learn from these, and then it is going to understand the pattern. It is going to understand, okay, so if the house has swimming pool, the price gonna be higher, or if the house has more bedroom, the price gonna be higher. So next, if you're going to ask a question from your model, okay, my house has 3 bedroom but no swimming pool, but this, based on the data which he already learned the pattern, he can give you the approximate output. So that output can be so accurate. It depends how much you train your data and how much your model is accurate, or that output can be just random because maybe your model is not accurate enough. So I talk a lot, but anyway, it's so cool. So here I don't think we have any. Actually, we can talk about this. Machine learning entails a three-step process: data, model, action. So to learn, like exactly like human, if you want to learn something, you have to get data, and then you're gonna use your brain, which is the model. Learn from the data. You're training your data with your brain, and then doing something which is action. For example, if you want to learn like new language, you have to first watch some videos, read some books, so injecting some data to your model, which is your brain, and then action, then you can talk in that language. So and then here I think you talk about the example, full example. So here machine learning, so here to incorporate machine learning into our spam detection system. Imagine we have a spam detection system. So we're trying to create a project for a spam detection system. So we're trying to create a model to detect the spam, like emails or whatever. We need to switch out comments for data and add model in order to produce an action output. In this example, the data comprise sample emails. and the model consists of statistical based rules. The parameter of the model and the model consists of statistical based rules. The parameter of the model here, let us go. So yeah, include the same keyword from uh, from our original negative list. The model is then trained and tested against the data. So we're trying to create a spam detection system. We're gonna give data, and then the model need to learn from the data, and that data contains list of example spam emails with a different keyword inside that email, which we're going to read right now. Once the data is fed into the model, there is a strong chance that assumption contained in the model will lead to some inaccurate prediction. For example, under the rules of this model, the following email subject line would automatically be classified as spam. PayPal has received your payment for Casino Royal purchase on eBay. So look at these keywords: PayPal, payment, Casino. So these keywords, imagine that your model gonna detect this as a spam because of the data which you already trained and because of the way how you train the data. So how you train your model with that data. So the model gonna think that every time if the email contain these keywords, it's spam, but not every time, so it's not accurate enough, right? As this is a genuine email sent from PayPal autoresponder. The spam detection system is lured into a producing a false positive based on the negative list of keywords contained in the model. Traditional program is highly susceptible to such case because there is no built-in mechanism to test assumption and modify the rules of the model. Machine learning, on the other hand, can adopt and modify assumption through its three-step process. So simply just talking about the example and then how the machine learning can be accurate in this example, which is a spam detection system, or how much it can be not accurate. So, and it can make a decision based on the data, sometimes false, sometimes true. So here, this part is important. What is training and what is test data? So I'm gonna explain to you. So when you wanna create your model, like about any project, imagine that spam detection system. You have training data and you have test data. So training data is a data which you're going to feed it into your model, so your model gonna learn from that training data. And test data is the data which you're going to use it after your model already get trained, but that training data, you're gonna use that test data to test your model accuracy. So it's like, first of all, you're gonna train your model with training data, which is a separate data, and then after your model get trained and you make sure that it's accurate, if you want to make sure that it's accurate enough, then you have to test it, right? So you're going to use the test data to test your accuracy, to test the accuracy of your model. So that's the way it works. So here even we have a category like computer science. So it's explaining about like machine learning is under the AI is under data science, data science is under computer science. So it's kind of like that. So it's like computer science is everything. Data science, AI, machine learning, and even if we have this circle here, which is computer science, then inside that we have data science, and inside that we have AI, machine learning, and data mining. And inside the AI, we have machine learning. So it's like we understand from this picture that machine learning is is in the category of AI. So it's like every AI, every machine learning is AI, but every AI is not machine learning because we have deep learning too. So that's the way how it works. So every machine learning is AI, but every AI is not machine learning. But every AI is data science. And every data science is under the computer science. So that's the way how it works. Let's see what else. Actually, this is extra information about that. And then we have ML categories. So we have some ML like model categories. We have supervised learning, we have unsupervised learning, we have here reinforcement learning, and we have this is the next chapter which we don't talk about it. So now we're gonna talk about these. gonna show you. So let me open up the book because I think doesn't have one thing. Two. So it is two. Actually, it is three. So let me ML categories. I think this is done. The chapter two is done. Oh yeah, machine learning categories. The chapter two is done. So until here, actually until here, the chapter two is done. This is chapter three, which is machine learning categories or ML categories, which I'm going to talk about it tomorrow. But today we already learned about whole of the chapter two, which I have the book here. So we learn about what is machine learning, the date which it comes and how does it come and so on. Like how does it works, input, data, model, output, what is predefined as predefined programming, like traditional way of programming, what is different between machine learning and that, what is training and test data, training data and test data. And we learn about the anatomy of machine learning, which I explained. Like machine learning is under AI, AI is under data science, and data science is under computer science. And and that's all. And we have and tomorrow, like the next day, we're gonna learn about the category of machine learning, which we have supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning, and so on. So anyway, so far we learned a lot. So I hope you like this tutorial. So this is the second day and we are in chapter 2 and tomorrow is going to be chapter 3. Okay, so tomorrow we're going to talk about all of these machine learning categories, which is that chapter 3. Okay, don't forget to subscribe my channel if you like these kind of videos. And that's all. If you have any question, just comment me below. I'm gonna answer it. Take care. Goodbye.